met today. And the last time we met, I finished with example 1 and example 2, and we were calculating limits algebraically. And so I'm going to pick up where we left off, so I'm going to do example 3 now. Now, if you recall, because of the definition of limit, remember, in order for a function to have a limit, or I should say, in order for a function to be continuous, not only does the limit have to exist, but also the function value has to exist, okay? Let me just write this out as a refresher from last time. So where do I want to write this? Hold on. I think I'm going to write it down here. Note. Okay, so in order for a function to be continuous, the limit as x approaches a of our function f of x is equal to the function value at a. So if you're looking for the limit of a continuous function, all you do is plug in your a and into the function, and then that will be your limit value, okay? But this only works for continuous functions, okay? That's an A. So if you have a function that's not continuous at A, then you've got to do something different. So let's do an example like that, because the first 2 examples that I did last time on Tuesday were of the types of continuous function. The first example was a constant function, and then the second example was a parabola or a polynomial. So those are continuous functions. Lines, quadratics, constant functions are continuous. So it's pretty easy to do the problem. However, let's look at this example. We have the limit as x approaches 4 of 2x squared minus 7x minus 4 divided by x minus 4. If we plug in 4, we get an undefined result. Notice if I plug 4 here, I get 4 minus 4. That's 0 in the denominator. So that's a problem. Okay, so it's not continuous at 4. And what we've got here is 2 times 4 squared minus 7 times 4 minus 4 over 4 minus 4. You're maybe wondering, well, you know that's undefined. Why are you calculating it? Well, what I want to show you here is it turns out that not only is the denominator 0, but the numerator is also 0, because we have 2 times 4 squared, that's 32, because 2 times 16 is 32. 7 times 4 is 28, so I have 32 minus 28, that's 4, minus 4 is 0. So it's in the form 0 over 0, and there's something special about this form. If you take your 4, plug it into your function, in other words, you're calculating f of 4, and if you get 0 divided by 0, There's a hint there. And the hint is when you see that, you know to factor your function. So when you see that 0 over 0, so your first step in calculating limits algebraically is always to plug the number in. You take your 4, plug it in. When you see that 0 over 0, that means your next step is to factor. So that's what I'm going to do. So I'm continuing here. Now let's talk about how we factor this. This is a parabola or quadratic function. And so I'm going to pause this for a minute and go to another page. This is kind of an aside. This is a review from algebra for now to show you. When I factor quadratics, especially when I'm teaching, I typically use the AC method. So let me review that for you. So we have our 2x squared minus 7x minus 4. I want to factor this. This is a quadratic, so it has the form ax squared plus bx plus c. A is equal to 2, c is negative 4. So the AC method just means you multiply those two numbers together. So AC is equal to negative 8. 2 times negative 4. Okay. Now I want to factor this. I want to factor 8. The factors of 8 are 1 and 8, 2 and 4. Those are the pairs of factors. Because this product here is negative 8, that's a negative, I know that I'm going to have one of my factors has to be negative in order for the product to be negative. I want the product to be negative 8. I want the sum to be negative 7. Okay, let me just write that down so you can refer to this later in your notes. Okay, well, I'm looking at the choices. I only have 2 choices, so this shouldn't be too hard. If you notice, if this 8 were negative and this 1 is positive, 1 times negative 8 gives me the negative 8. And also the sum, negative 8 plus 1, will give me negative 7. So this is the choice that I want to select right here, and I want that to be a negative. Now that I've figured that out, I'm going to go ahead and split the middle term. Okay, when we split the middle term, it's going to look like this. I'm going to replace negative 7x with negative 8x plus x. See how that combines to give me negative 7x? So I just took this and split it. These coefficients, here's 1, here's negative 8, come from this over here. So that, and it doesn't matter what order you write them in. You can put the x first and then the negative 8x. You're going to get the same answer either way, so don't worry about that order. Then I've got 2x squared minus 7x minus 4. This allows me to group the terms together and factor them separately. So this factor is going to be 2x times x minus 4. This I can't really factor, but I want this to match this, and it does. So I'm going to write it as plus 1 x minus 4. Now, if I take, here I have 1 times x minus 4, here I have 2x times x minus 4. If I bring out the x minus 4, I'm left with 2x plus 1. And there I have factored my quadratic. Okay, if you're rusty on this or you've never seen this method before, you can go to YouTube, type in AC method factoring, and you'll get tons of videos with this method and how to do it. So if you want to try some other examples, go take a look at that. Or if you're comfortable factoring quadratics your own way, then don't change your method. I didn't really discover this method until I was almost 50. So, you know, just because I did it a different way. But I found for teaching, the way that I did it myself was confusing for students. And this AC method works for every quadratic function that can be factored. And so because it's so systematic and easy to explain, and it always works for everything, I just have adopted this method now for teaching purposes. But you can factor however you want to. So back to the calculus. So now that we've factored, here's my function. I factored the numerator as x minus 4 times 2x plus 1. And it's divided by x minus 4. And lo and behold, we can factor or cancel out that factor. So this becomes equal to the limit as x approaches 4 to x plus 1. Now we've reduced this to a continuous function. And remember, for a continuous function, in order for it to be continuous, you've got the limit as x approaches, in this case, 4 of our function 2x plus 1. All we have to do is plug in our number. So that's what I'm going to do now. I plug in 4. 2 times 4 plus 1 is equal to 9. And there's my limit. So just to recap what this example shows, if your function is not continuous, and when you plug in when you plug in that point and you get 0, 0, you know you have to factor, something is going to cancel, and then you plug in your number into that new function. And there you have it. Any questions on that? Can you all hear me? It looks like you can.
No, ma'am.
I forgot to turn on my audio. So I did the first example or first 2 examples. It was like nobody could hear me. So if that ever happens again, just unmute yourself, because I don't always look at the chat box. And so just let me know, hey, you got to turn on your audio. So anyway, if there are no questions, let me continue on to example 4. Okay, example 4. We want to calculate the limit as x approaches 5 of x squared minus 25 over x minus 5. And if we try to plug in, we get f of 5 is equal to 5 squared minus 25 divided by 5 minus 5. All right. 5 squared is 25 minus 25 over 5 minus 5. And you'll see I get 0 over 0. And of course, this means factor your function. Now, this is not a trinomial. This is a different form. So let's talk about the difference of squares. And maybe you remember from algebra, a squared minus b squared equals a plus b times a minus b. This is the format, the formula of the difference of squares. So in our particular example, the x corresponds to the a. So instead of a squared, we have x squared. And the b corresponds to 5 because 5 squared is 25. So using this model, this is going to be the limit as x approaches 5 of x plus 5 times x minus 5 divided by x minus 5. And you can see now we have a common factor. That's because we got 0 over 0. So there's my common factor. And we plug that 5 in into my x plus 5. We get 5 plus 5, which is 10. Okay. Let's suppose we want to calculate the limit now as x approaches 5 of x cubed minus 125 over x minus 5. So it's very similar to the problem I just did. However, this time we have the difference of cubes. And just to refresh your memory on that, how to factor that, because you'll notice if I plug in 5 here, 5 cubed minus 125 is 0 because 5 cubed is 125 and you subtract 125. And then if I plug 5 in here, I get 0 also. So we have the same situation, 0 divided by 0. So I want to factor. Oh, let me do a cubed. That's the form minus b cubed. And that's a minus b times a squared plus ab plus b squared. And just as an added bonus, we don't need it for this problem, but just as a reminder to you, if you run into it, a cubed plus b cubed is a plus b, a squared minus ab plus b squared. So this is the difference of cubes, and this is the difference of square, or sum of cubes. I don't know what I'm thinking of. Sum of cubes. There we go. Okay. All right, continuing with the problem, I'm going to factor this. I just took my x and my, so this is x cubed, this is 5 cubed. I took the x and the 5 for a and b and plugged them into this formula. So I get x minus 5, x squared plus x times 5, or 5x, plus 5 squared, which is 25. So I just plug those in. And then, of course, we have to divide. And don't forget your limit as x approaches 5, like that. I forgot to write that. Okay, but the point is, because this, when I plugged in 5, I got 0 over 0. I know that I'm going to have a terms that can factor or reduce, simplify to 1. So those cancel out. And now we get the limit as x approaches 5 of x squared plus 5x plus 25. So we've reduced this now to a continuous function. Because it's continuous, I know that all I have to do is plug this number in and I will get the limit value. So plugging in 5 for x, I get 5 squared plus 5 times 5 plus 25. Which works out to 3 25s, and that's 75. Okay, any questions on that one? So again, these are relying on some algebra here. So this is kind of a refresher for that. Now, there are a lot of problems like this where you have to factor. You get 0 over 0 and you have to factor. There are not so many problems on the limits of infinity, but I want to do 2 examples because I do know there are 2 homework problems at the end. The last 2 homework problems deal with limits of infinity. And I just want to show you how you do those 2. So example 6, we're going to take the limit as x approaches infinity of 3x cubed minus 2x squared plus 1 over 4x cubed plus x minus 10. Now, just like on the other problems, your temptation might be to try and plug in infinity. Well, of course, infinity is not a number, so we can't do that. So we have to use some different methods to solve this type of problem. But whenever you're working with infinity, what happens is when you have powers on x, even though this 3 is only 1 more than 2, for very, very large numbers, this extra power is going to just swamp this right here. So basically, because this is the most powerful term, because we have a cube, and here we just have a square, and here we have a constant term, this is going to get swallowed up. So I can kind of ignore these, okay? So I'm just going to kind of put this little hatch mark through there just to say we're just going to kind of ignore those values. They're there, but for really large numbers, they're inconsequential. So these 2 most powerful terms are battling it out. But as it turns out, notice they both have the same highest power. That's called the degree of the polynomial. They're both identical. So they're not really, they're battling it out, but they're pretty evenly matched. The difference is, and if you think about it, the way, because these are inconsequential for really large numbers, this limit is equivalent to (3x cubed over 4x cubed). And now, what is this? This is just 1, right? So this becomes 3/4, and that's our limiting value. It's kind of interesting, but it's a very different approach because we're dealing with infinity as opposed to a constant number. Okay, another example involving infinity. Let's look at that. X squared minus 3x plus 1 divided by x cubed minus 2x squared plus 3x minus 18. So now the numerator and denominator are battling it out. X squared is the most powerful in the top here in the numerator. X cubed is the most powerful in the denominator. These guys right here, they're not helping very much, so we're just going to pretend they don't exist. They're just not helping. X squared is way more powerful than negative 3x plus 1. Same here for x cubed, way more powerful. So it's kind of think of it, this is one team, the numerator is one team, and the denominator is another team, but these two dominate on the team. They're going to determine the outcome of the battle, okay? Well, obviously, this guy down here is way more powerful. But to show you the algebra, let me show you how this works. I'm going to rewrite this as the limit as x approaches infinity of 1 times x squared, that's the numerator, and the denominator is x times x squared. These are equal to 1 basically, so this becomes the limit as x approaches infinity of 1 over x. Now think about it. If you take a huge number like a million, take 1 divided by a million, that's really close to 0, right? If you take 1 over 10 million, that's even closer to 0. And if you take 1 over, I don't know, what is it? My son has this, my 7-year-old son, he has a name for something. It's a modern term, and I don't even know. He says it, a golgon. Have you guys ever heard of that? I guess it's just an enormous number. Anyway, I don't even know what it is. I'll have to Google that, but he uses that term. He picked it up somewhere. And so if you have 1 divided by a golgon or whatever it is, that's just so close to 0. It might as well equal 0, right? Okay. I'll have to look at that up. I can't remember what term he calls it, but anyway. So that's how you work with limits of infinity. And there are only two problems like this in your homework, and both of them are very similar to these two. So you should be able to do those problems. There's one other problem in your homework that I think you'll have a difficult time knowing how to do. So I want to do an example, or maybe it may be even the identical problem, but it's very similar, if not the identical problem. So example 8. This time we're finding the limit as x approaches 100 of the square root of x minus 10 divided by x minus 100. And just like the other problems, the first step, maybe I should write these out so you can have these in your notes. Step for solving limits algebraically. So the first step always is plug in x. If you get a number out, you're done. Okay, the second step is if your answer is 0 divided by 0, then factor. Okay? So, wait a minute there. So the first step here is I'm going to plug in 100. And you can see 100 square root minus 10 over 100 minus 100. You can see that's 0 over 0. So that's my clue that I'm going to have to factor. However, how do I factor this? That's a square root. I don't even know what to do with that. So we use, in mathematics, when something is messy looking and we don't know what to do with it, we use U substitution. So I'm going to make a U substitution. There's nothing special about the letter U. It's just an arbitrary letter. But it's used commonly in math for substituting. I don't know why. So we say a U substitution. And the offending part of this problem is the square root. I just don't like square roots. I don't know what to do with them. So I'm just going to say, well, forget the square root. Let's let U equal the square root of X. So I just give it another name that's more palatable, okay? But at the end of the problem, I can go back and convert it back to the square root of X so that I haven't lost my original problem. So here we get, it becomes the limit. This now is U minus 10. And X, if the square root of X is U, then X is U squared, right? So this is going to be U squared minus 100. Okay, but I'm not quite set here. I still have the problem of, to solve this, I have to plug in my number, but I can't plug in 100. Why? Because 100 is really an X value, and I'm working with U's. I have to convert this 100. So if X is approaching 100, what does U approach? Well, remember, U is the square root of X. So U is going to approach the square root of 100. So to write this properly, I have to say the limit as U approaches 10, U minus 10 over U squared minus 100, okay? Now everything is in a format that I can work with. I've got all U's, and I know how to deal with this. Notice if I plug in a 10, 10 minus 10 is 0. 10 squared minus 100 is 0. So I know that I'm going to get 0 over 0. So the next step is to factor, right? If your answer is 0 over 0, then factor. And so U approaches 10. U minus 10 divided by, this is the difference of squares. This is U squared and this is 10 squared. So that's going to be U plus 10, U minus 10. And this will cancel with that. And then this becomes the limit as U approaches 10 of 1 over U plus 10. Well, I can just plug in my 10 and I get 1 over 20. That's easy enough. I should have written that out. 1 over 10 plus 10. Plug in U equals 10 to get that. Sorry, there we go. Okay, so that is a trick. It's called U substitution. I think there may be only one problem like that in your homework, but here, following this example, you'll know how to do it.